A lot of fresh graduates come to our offices for their technical trainings and induction. But here is the most important thing I have noticed. They have thousands of questions in their mind, but they don't even ask them. And that's the problem. In the technical field, if you're not asking the right questions, the questions can actually hold you back. If there is any topic that you're confused about or you want someone to explain in depth, I'm here. Just put it down in the comment section. This channel is here to help you what you should learn. It's not just what you have been told. This When people hear the word ship, they imagine one thing: a giant metal box floating on the water. Yeah, big, slow, rusty, carrying something. But that's not reality. Not even close. Ships are not just floating boxes. Ships are tools, and every tool is built for one specific job. You change the job, the entire ship changes. The shape, the strength, the engine changes, even the inside layout changes. Would like to understand today why the ships look the way they do. Yeah, sure. But before we start, I'll tell you the categories of the ship. There are four categories of the ship: cargo ship, passenger ship, naval and military ships, and offshore supply vessels. So, cargo ships, these ships don't carry people, they carry the world's economy. So, let's start with what we recognize because we see it most of the time: container ships. These ships carry standardized steel containers, same weight, same length, same blocking system, and that standardization has changed the global trade forever. Because every container fits perfectly into ship, train, and truck, irrespective of what's the cargo inside it, and you don't have to remove the cargo. So that's the feasibility. Inside the cargo holds, there are vertical steel rails. We call them cell guides. They guide the containers down into the position and keep them steady in the rough seas. Because on the deck, the containers are stacked high, very high. So the structural strength and stability here are so critical. And the speed matters too, right? It's very much. Container ships run on very tight schedules because unlike the bulk carriers, they don't just arrive when they arrive. They operate on a fixed routes, fixed ports, and fixed time windows. So it's like a bus service. You can call them as a global bus service for cargo. But now here is the most important part. When one thing goes wrong, everything shifts. If a bad weather slows a ship, if a port is congested, if a crane breaks down during loading, if the mechanical issue on board, the ship gets delayed. Sometimes loading and onboard repair happen simultaneously, and that coordination itself can cause the delay. If the ship misses its berth slot, it must wait outside the port. Because what happens is the ports allocate the berth slots in advance. Missing your slot, it means waiting outside, and waiting means fuel consumption, your crew cost, charter penalties, and you disrupt the whole supply chain. So that delay doesn't just affect the ship, not at all. That container might carry the spare parts for factory, the medical supplies, the retail goods for stores. If the ship is being late, the factories stop production, stores run out of the stock, prices go up. That's how you manage the supply and demand. I'll give you an example. Like if your online order is being delayed, you blame the seller, you put the grievances, you blame the seller, you give your feedbacks. But what happens is often the delay happened thousands of miles away at the sea. So one delayed container ship can disturb the whole supply chain across the multiple countries. So when you say time is money, it's not just the fuel cost. No. It's economic ripple effect. Container shipping works because of synchronization. You break the timing and the entire system feels it. Now the bulk carriers, they look different, more open, less stacked. It feels like there is nothing in them. Yeah, because they carry the loose cargo: coal, iron ore, grain, cement, no containers, no packaging at all. The cargo is directly poured into the massive open holds. So what's the engineering challenge in that? The weight itself. They carry the extreme weight, and uneven loading can twist the hull. So the bulk carriers are built incredibly strong, by the way. And they are slower than the container ship because they carry the enormous mass into them. And they don't care about the beauty, they care about the strength. Then the liquids must change everything, right? Well, completely. because liquid moves, it shifts, it creates instability. So the tankers are divided into multiple cargo tanks to reduce the sloshing effect. There are different types like crude oil tankers, product tankers for fuels, chemical tankers, and the gas carriers like LNG and LPG vessels. And what about the overall safety? Yeah, safety is so critical here. Tankers use inert gas system to reduce the oxygen levels inside the tanks, preventing explosions. On a tanker, one mistake doesn't just damage the cargo, it damages the entire ocean. And for that, the international regulations like MARPOL strictly control the pollution, because one mistake doesn't just damage the cargo, it damages the marine life, it damages the ecosystem, it damages the coastlines. And the ships which carry the vehicles only, what about them? Roro ship, they carry the vehicles, cars, trucks, trailers. Instead of the cranes, they use the rams. Vehicles literally drive in and out of the ship. Inside, it looks like a multi-story parking garage. You can call it like floating parking structures. General cargo ships are very flexible. They carry pallets, crates, machinery, drums, mixed cargo. They are useful where the container infrastructure doesn't exist. And reefer ships, they carry the refrigerated cargo, fruits, meats, medicines, where the temperature is life. They are designed with the backup power and the redundant refrigeration system, because cargo doesn't spoil because of time, it spoils because of the uncontrolled environment. Oh, I see. They are called reefers, huh? Because I was really curious about it. Well, where cargo ships move the good, passenger ships move lives. So cruise ships are floating cities. Yeah, floating cities, floating hotels. Comfort here matters more than the speed. They are built on extreme power redundancy because thousands of people depend on electricity, food system, water system. A cruise ship is about enjoying the beautiful journey. It's not about reaching somewhere fast. For that, we have the ocean liners. Yeah, is it? I used to think like the cruise ships and the ocean liners are all same. Big passenger ships, luxurious and multiple decks. No, 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 no. Ocean liners are completely different story. They are built for the long distance ocean crossings, stronger hulls, heavy weather capability. They were built to fight the sea. And both cruise ships and ocean liners serve the different purposes. An ocean liner is built for transportation. It has one job: get the people from point A and to the point B reliably across the open ocean. A cruise ship is built for experience. The journey is the destination here. Ocean liners needed a scheduled reliability regardless of the weather. They maintain high service speeds to cross the oceans quickly. And whereas the cruise ships operate slower, fuel efficiency and the passenger comfort matters here more than the speed. So one moves the people and the other entertains the people. Yeah, exactly. All right. And what about the routes? Ocean liners sell fixed long distance routes, historically, like Europe to North America. Cruise ships operate circular itineraries. They start and end at the same port. They don't need to cross the oceans. So, here is the cleanest way to say it: an ocean liner is built to survive the ocean, whereas the cruise ship is built to enjoy the journey. Now, ferries operate like short distance. They run like daily taxis, vehicles and passengers they carry. They are like highways on the water. Well, now these ships they don't trade; they protect. Aircraft carriers are the floating air bases. They carry the aircraft, fuel, logistics, and thousands of crew. Whereas the destroyers and frigates focus on speed, radar, and missile systems. You might know submarines operate underwater with advanced life support and the stealth technology. A submarine is the ship that survives underwater. These ships are about defense and strategy more. Well, this ship they don't carry cargo. They support the other ships. I remember I have seen some boats carrying the biggest one. Why is that? Yeah, obviously, they called tugboats. So tugboats are small but extremely powerful. They push and pull the massive ships inside and outside the port because the large ships are not designed for the tight maneuvering in the port. Their main engines are built for continuous ocean speed, not to delicate movements in the confined waters. If the massive ship uses the full propulsion near a port, the propeller wash can damage the quay walls. Suction can affect the nearby vessels, and the steering becomes very limited at the slow speed. Tugboats provide the control lateral force. So they push, they pull, they rotate ship very precisely. Small size, but the massive torque. Without tugboats, the ports would be like chaos. So it means icebreakers don't avoid the ice, they attack it. And how they do it exactly? Their hull is reinforced and specially shaped. Instead of cutting the ice, they ride up onto it. The ship's weight crushes the ice from above. Some icebreakers use the powerful propulsion system to ram forward, reverse, and then ram again. They are built to operate in extreme cold with the strengthened hull plating and the protected systems. They don't fight sea, they fight the frozen sea. Now, what about the offshore supply vessels? What exactly they do? Well, think of oil rigs and the wind farms. They are like remote industrial platforms in the middle of the ocean. They need constant supplies, fuel, fresh water, drilling mud, equipment, crew. And that's where the offshore supply vessels, OSVs, come in. They are the logistics lifeline. I'll tell you what makes the OSVs different. OSVs are designed with larger open cargo decks at the rear, powerful dynamic positioning system. Oh, what's that? Dynamic positioning mean? It allows the vessels to hold its exact position using the thruster and computerized system, even in the wind and the waves. Because when you are transferring the cargo next to the massive oil platform, you cannot just drift, because even a small movement can damage the structures or the pipelines. Some offshore supply vessels also handle anchor handling for drilling rigs, towing large offshore supply structures, emergency response. They operate in very harsh conditions. And unlike the cargo ships, they don't follow the global routes. They operate repeatedly between the port and the offshore installations. Short run, high precision, very high risk. Then comes dredgers. Have you ever heard they say man-made island, or how the seabed is deepened? That's called dredging. Dredgers excavate the sand and seabed material. They deepen the ports so the larger ship can enter. They reclaim the land. They reshape coastlines. Without dredging, many modern ports wouldn't exist. Trade would shrink. Then come fishing vessels. Fishing vessels are like floating production plants. They don't just catch fish, they process, clean, freeze, store, all on board. Some stay at sea for weeks, for months, factories, operations in the middle of the ocean. So these ships don't carry global trade like container ships. No, they make global trade possible. They support, they protect, they prepare. Sometimes the most important ships are the ones nobody notices. Now, most of the time we hear the names like Panama, SUEZ, AFRAMAX. Oh well, they are not the types of the ships. They are the size categories based on the physical limitation. I'll tell you. These names come from geography, not from cargo. Let's break them down like properly. Panamax refers to the ship design to fit the original Panama Canal locks. The size limits of the Panama Canal roughly are like length 294 meters, if I'm not wrong. Beam width it's 32.5 meters. The draft should be 12 meters, and the deadweight ton should be around 65,000 to 80,000 deadweight tons. So it's about dimensions and not the cargo. Exactly. If you were even slightly wider, you couldn't pass. And why does that matter? Because the Panama Canal connects the Atlantic and Pacific Oceans. Without it, the ships must go around South America, and that means thousands of extra nautical miles. The Suez Max, right? So the Suez Max refers to the maximum ship size that can pass through the Suez Canal, fully loaded. The typical limits are the deadweight ton should be like 120,000 to 200,000 deadweight tons. The draft limit around 20 meters, varies with the dredging updates. No lock width restriction like Panama, but the draft is very critical here. So the Suez is more about depth. Yes, correct. The canal is sea level, no locks. So the draft, how deep the ship sits in the water, is the limiting factor. If the tanker is too heavy and sits too deep, it cannot pass. That's why the size optimization matters in the global oil trade. Without Suez, the ships go around Africa via the Cape of Good Hope, and that adds the massive time and the fuel cost. Different. It doesn't come from the canal. It comes from the average freight rate assessment. AFRAMAX tankers are typically 80,000 to 120,000 deadweight ton. They are like medium-sized crude oil tankers. And so why are they important? Because they are extremely versatile. They can access more ports than any VLCCs. VLCC stands for very large crude carriers. So they are port friendly, flexible, common worldwide. They don't need to depend on the Canal Maximus. So here is the real understanding. Panamax designed to fit the original Panama Canal locks, deadweight tons 65,000 to 80,000 deadweight tons, where Suez Max is maximum size that can fit in the Suez Canal draft limit. Okay, and the AFRAMAX is medium crude tanker class. So these names don't describe what the ship carries. They describe where the ship can go and how heavy it can be while doing it. Alright, so it's not about cargo. No, it's about geography, controlling engineering. The ocean is open, but the trade routes have limits, and the ships are built around those limits. They are purpose-built machines. Understand the purpose and everything makes sense. The shape, the strength, the engine, the layout. Ships are tools and the ocean is their workplace.